In this video, I host a Q&A where I answer my students' questions. In particular, we're going to have a look at composite functions and inverse functions. Enjoy. Glad to hear it. How can I help?
Um, so, okay, wait, let me just, there's a question in chapter one. Let me just see where,
Is this
in
Unit
chapter one,
3
year 12
for
methods,
Year
yeah.
12? Okay. Yep. Possibly composite functions if I were to take a stab.
Um, yep, it was chapter 1F, question 7H.
Inverses. Okay.
Yeah.
1F, 7H. Let's have a look. 7H, you have a semicircle. Okay, makes sense. But we're doing it specifically from 0 to 2. Okay, let's see. So when you saw this question, did you try anything in particular, or did you just kind of get stuck as you started?
I kind of got stuck.
Okay, that's fair. So we're told, let's just start writing it out. One thing I'll ask is, do you remember how to toggle between all the screens?
Yes.
Okay, that's good. So we're doing the majority of this through the handwritten bit. So we have square root of 4 minus x squared, and specifically we have x an element of x an element of 0 to 2. Okay, and that is all on screen. Cool. So when you do inverses of any function, what's the first thing you typically do?
Usually substitute, like, x as y, and then, like, hx as x.
Yeah, sounds good to me. 4 minus y squared. Okay, and what do you do next?
And then you just basically, like, solve for y when
Yep,
you, like, have done the substitutions.
easy enough for you to solve for y here, or do you need to see how that works?
Um, I think it should be easy, yeah.
Okay, so what do you do next to get y on its own?
Okay, so you take the root sign to the other other side, so x squared,
Yep.
and then you take the 4 to the other side, then it's x squared minus 4 minus y squared. Then you divide it by minus 1 on both sides.
Yep.
Then you square root the other side, both sides.
Hmm. Okay. I mean, it sounds like you're doing pretty much everything you need.
Yeah.
The only thing you're running into here is this plus minus.
Can you simplify that further?
Yeah, in fact, you have to.
Oh, okay.
Because, well, let's see. Yeah, there has been an example. Part F. Did you do 7F before?
Yeah, I have.
Okay. Do you remember what you had to do for part F? How you had to simplify things?
Yeah. No, I don't know.
Okay. Um, did you do part F? Because basically what I'm trying to say is, have you done the inverse of a quadratic before?
Yeah, I have.
Okay. Do you remember what you had to do at the end to make it work?
Do you have to like difference of two squares, or like
Uh,
something like that?
Difference of two squares? Probably not. Um, whenever you do the inverse of a quadratic, you typically get a square root with plus minus in it,
Hmm.
which is why I'm drawing that parallel. Um, so the way you get around this is, if you think about what this looks like on a graph, in fact, I can even just cas it out so we don't even have any ambiguity, would be something like this. It will turn out to be a relation. So if I were to do the square root of 4 minus x squared, that would give you the positive portion of the circle, and then the
Hmm.
minus portion would be the bottom portion, right? So 4
Right.
minus x squared. And what you end up with is a circle, which is a relation, not a function. We're looking
Right.
for an inverse function specifically.
Hmm.
So what we have to keep in mind is that when you're doing your math up here, the math hasn't considered that you have this restriction on your domain on this function, right? It doesn't, in
Right.
fact, furthermore, it doesn't know that you only mean the positive of this square root.
Mm.
So when you're doing your rearranging and squaring things and getting it back into square roots, you're kind of losing a bit of information as you do it. So
Right.
more realistically, this graph should look like so. So we're doing from 0 to 2, so 0 less than equal to x less than equal to 2. You could put the actual equal signs in there, but it doesn't really matter. We're just trying to show what it looks like. And what you see is that you actually get only a portion of that graph.
Mm. Okay, good. All right.
And so when you go ahead and try to find the inverse of that blue portion, the inverse of any function is just its reflection in the line y equals x.
Right.
Remember that?
Yeah. Yeah.
So when you have a situation where you have plus or minus the square root of 4 minus x squared as your inverse, you'll notice that it's basically the same as what you started. So compare here and here, right? Those are pretty much the same graph, except one's got a plus and a minus on it.
Right.
So if you're looking at what we currently have here, we have expressed the negative of that root. The positive of that root would obviously be the blue. When you
Yeah.
think about the line y equals x, what do you think this inverse function should look like to make it look like it's reflected along the line y equals x?
Sorry, I couldn't catch like the question. Like, what do you mean by that?
So we have two options, right? We have either the positive or the negative as our inverse.
Yeah.
That's what we have here. We have to pick one that would actually make sense.
Okay.
The original function looks like this. All right, this is
Mm.
just f of x, we'll call it.
Okay.
Now, to have an inverse, we need to reflect this thing along the line, or about the line y equals x. Now, if you were to reflect this function about the line y equals x, would anything change?
I mean, yeah, it would just be flipped.
Would it? What would it look like?
Like, uh,
I know this is a bit, maybe
like
it's a bit
I don't know how
sketchy.
to describe it.
What I'm trying to say is that this is supposed to be symmetrical already. Like if you look at
Hmm.
how it looks like in the blue specifically, that's already symmetrical. Like if you were to, I guess maybe I'll even angle it this way, you can see that any pair of dots are equidistant either side. They're already symmetrical there.
Yeah.
So what I'm trying to get at is that the inverse of the circle, or at least this portion of the semicircle, is itself. You pick the
Hmm.
positive root to be your inverse as well.
Okay.
Does that make any sense?
Yeah, I understand. I'm just not sure, like, how you would decide, like, which one to choose, like the plus or like
Mhm.
the minus.
Yeah, so that brings us to the next thing. So now that you've seen what it looks like graphically and why it would be the positive version, now we look at what would you have to do tech-free to get it to work that way. So when it comes to inverses, what's the rule about domain and range?
There'd be swaps.
Yep. So range of the inverse is goes to domain of f. Domain of inverse is range of f. Cool. So currently we already know domain of f, or in this case it's h. Domain is 0 to 2, and so we expect our range of our square root to be 0 to 2.
Hmm.
Sound fair?
Yeah.
Even just by looking at the range without even considering domain, which positive or negative would give you y values between 0 and 2?
Between 0 and 2.
Yeah, so you could even just test, right? Like let's say there's one option where you've got the square root, the positive root, so 4 minus x squared, and there's one version where you've got the negative, and we're targeting a range of 0 to 2. Which of these is likely to give positive y values, or, from 0 to 2?
The positive root
Yeah,
of
the
4
positive one.
minus 6.
Correct.
Fine.
So even if you know nothing about the inside of this graph, you know for certain that if there's a negative out here, you're going to get negative y values. And if there's a
Yeah.
positive, you're going to get positive. So that's a tech-free way that you can handle this without even knowing the fact that this is a semicircle. You can just look at domain and range of your function and then use that to figure out which of the roots are acceptable.
Okay.
So the
So if
fair,
you want to find out, like, sorry.
go ahead. Yep.
Oh, yeah. So if you want to just find out, like, which of the two square root functions is like applicable, you just have to sub in the domain, like range,
Yeah,
like
you
domain.
basically test. So you look at the domain of the original, that becomes the range of the inverse, and you have to look which one would most be applicable. You
Right.
would have had to do
Right.
something similar for f. So I'll quickly run through f, which was you had g of x was x plus 1 all squared, and that's it. Okay. And the domain was negative 1 to 3.
Hmm.
So when you did this, it would have been swap your x and y, square root the x minus 1 equals y, and you'd have your plus minus on that.
All right.
So again, that would be a relation. If you were to draw both of those, it would be down 1 and something like this. Yeah.
Yeah.
So one thing you might have done would have been draw g as it was, which is a shift to left 1, like this, and this one caps out at 3, so I guess we can call this 3. And what you're basically looking for is which of these would look like the reflection. Is it going to be the top half or the bottom half? That's a graphical way of doing it, drawing both graphs and seeing which would look like what.
Okay.
Which is what we kind of discussed with the CAS, right? If you didn't know how to draw a
Hmm.
semicircle, then you could graphically do it like this.
Okay.
And then if you are struggling with the graphical version, you just say range of F inverse is domain of original. So which one of these is likely to give me a range of negative 1 to 3? Do I do the positive or do I do the negative root?
The negative.
Yeah. Oh, hang on. No, the negative
Oh
would
wait, no,
mean go
no,
downwards.
positive.
Yeah, the positive. So positive again, if you start with like x equals negative 1, well, sorry, this is a range. If you started at x equals 0, you would get that negative 1 because,
Hmm.
well, that cancels. And then
Yeah.
a certain x value later will give you y equals 3 because you got a positive root.
Right.
So
Okay. Okay.
that's basically that's the gist of how you do all inverse stuff that's more complicated.
Hmm.
Fair enough.
All right. Yeah. I got
Nice.
it.
Anything else I can help you with?
Um. Yeah. 1F question 13B.
Yeah, let's go for it. 13b. Okay. So this one is again a quadratic. It's talking about the same sort of idea that we are running into before. You have a quadratic, you can't naturally find an inverse of it, and so you have to split it into a one-to-one function to make it have an inverse. So we're still talking about the same kind of principle. Um, you know what? Now that we've had a conversation about it, I'm curious to see if you have any additional thoughts on this question now that we've done a similar question together.
Okay.
I'll let you have a read of that and let me know your thoughts.
I think I've got it.
Yeah. Okay. Nice.
Yeah. Yeah. So we know that G is like, B comma 2, and that's like the domain for GX. If it
Correct.
was the inverse, it would become the range.
Yep.
So B, since it's in front of the 2, it would have to be less than 2. So that means um so when we do the inverse of GX, it would definitely come out as like, a square root function, but I'm pretty sure we might need to use like the minus square root like inverse of GX,
I need to use
because
the minus. Okay.
yeah,
Yeah, keep going. Keep
because
going.
if we do that, then like, it would support like, B being lower than 2. Oh, but
Uh,
it asks B as the smallest real number.
mhm.
I was thinking B could be like negative infinity, but I didn't read that other part.
Okay,
I didn't
fair enough.
consider that. But,
Well, smallest real number. Guess negative infinity wouldn't be a real number per se, since it's not a number.
yeah.
But small numbers do include negatives. Doesn't
Hmm.
say positive. So like
Yeah.
that's yeah. The only flag there to worry about is the fact that infinity isn't a number. So that
Yeah.
might
Yeah.
tell you that there's something else there. But you're on the right track in the sense that you're talking about things once you start solving for the inverse, right? Being able to differentiate between the positive or negative, which one do you have? But solving for B specifically, um, that's going to come from this first statement here. Solve for B such that G has an inverse function. So what's the
Hmm.
criteria for something to have an inverse?
Something to Windows. Um,
Or I guess I should say inverse function, not just inverse, because that actually does matter.
mm, is it that uh when how do I say it? Like when the f like the f function is a composite of like the inverse function, then like all like wait, the domain is equal to the inverse of f.
I know what you're talking about, right?
Yeah,
So
yeah,
you're talking about this idea where it's like f of f inverse is equal to x, and the domain of that would be, well, this one would be domain of f inverse. Is that what you're
yeah,
talking
yeah,
about?
yeah.
That is a slightly different thing. Although I do like that that came up because this is something that very few people remember, and it's very helpful because sometimes you get really complicated composite functions, and you can just write this, which is nice. But for something to have an inverse, the thing that we need to make sure is that our function is one to one. Specifically, I should say
Um,
inverse function, because if you were just to take the inverse of this, then reflecting this in the line y equals x would mean this turning point of 1 here would go, let's call this 1. And, oh, hang on, I'm going to have to think about this. What would this look like? Something like that. No, I'm very bad at this. I'm trying to imagine this. This would go here, and like that. Yeah, okay, it's like this. If you were to do the inverse just naturally, you would get a relation, not a function.
right.
And so one of the criteria, or the criteria for an inverse function, is simply that you make sure this is a one-to-one function. So if you think about your domain of beta 2, you've currently got g of x, and it looks approximately like this. This would be, what, x equals 1, yeah. So 2 would be
Yeah.
somewhere out here, somewhere all the way out there. What would b have to be? What's the smallest value of b such that this becomes a one-to-one function?
Wouldn't it have to be 0?
0. Yeah. As
Yeah.
soon as you hit that turning point, anywhere above it would mean that you fail the horizontal line test. So theoretically, you could choose any value from here to 0, but they did say the smallest, and so you would have to give 0.
Okay.
So that gives you b. Yeah. So now you know that this is in fact g of x from 0 to 2. Then finding the inverse,
Mm,
well, we've already looked at how that works. Do you want to finish
right.
that one off yourself or go through it together like this?
Uh, yeah, we'll go through it together.
Okay, so finding the inverse of g, now that we know this is the domain, what do we do to start?
Okay, first you substitute g of x as x and then like x as y.
Yep, x equals 1 minus y squared.
You take the one to the other side and then it becomes x minus one,
Yep.
equal to minus y squared.
Mm-hmm.
Then you divide x minus one by minus one, and then you basically square root the whole thing.
Nice.
Oh yeah, plus and minus two.
Okay, so what do we do now?
Yeah. Now, um, since the range for the inverse function would be 0, comma 2, we just simply sub in like those values and see like, which of the two square root functions align with it.
Yep. Okay, so which of these is likely to give y values between 0 and 2?
Mm, it should be, well, hang on, wait.
So even if you just sub in some random values, like just any x values, because really all you care about, because it's 0 to 2, you're just looking for positive y's. You could get
Right.
more specific with it, and I'll show you that after you answer this, how you get more specific. But a good rule of thumb is if you're seeing positive y values for your range, just think which of these would give positive y's.
The positive square root
Yeah,
in this
positive square
function.
root.
Yeah.
So if you're looking to specifically aim for 0 to 2, like for example, if you're trying to figure out the domain of what y would have to, well, the inverse would have to be, that's where you go and look at the range of this function, because again, range and domain swap for inverses.
Mm.
So if we think about range of 1 minus x squared, you've got it from 0 and it caps out, somewhere down here at 2. You're basically looking at having a range upper bound of 1 and a lower bound of, well, 1 minus 2 squared, so negative 3. And these are inclusive, aren't they? They are, yeah. So that would be the range of g. So that's range g. To then figure out domain of the inverse of g, same thing. Domain g inverse. So what you can do is, if you want to be more mathematical about it, is find this first, test your x values into that, and see which ones give you the desired range of 0 to 2.
Okay, okay. All right.
So if I just do that, so I can show you an example. You got plus minus, let's say we set in negative 3, 1 minus minus 3. You've got plus minus the square root of 4, which is plus minus 2. So the negative root would have given you negative 2, the positive root would have given you positive 2. One of those is correct.
Mm,
And if
okay.
you don't like having a plus minus, you can just split it, right? You don't have to do plus minus. You can just do one with the positive, one with the negative. Then it's super clear which one did which.
Right.
Anything I should clarify more about that?
No, it's all good.
Okay, no worries. Okay, well that's that one then. So that's a pretty common question, right? Where you've got a restriction on your domain. Every time you have a
Mm,
restriction on your domain for inverses, it's talking about exactly this. It needs to be 1 to 1.
yeah.
Um,
All right.
cool with that?
And yeah. Look, I'm cool. I'm good.
Any other questions I can help you with?
There's also a question in 1G, question 4A.
Yep. Okay, for A, x equals, yeah, okay. So where do the two functions equal each other?
Yeah.
Uh,
Um, tried solving it, and then well, when I worked it out, I got x is equal to 1. But when I tried doing it on the CAS, it said like 0 was also a solution, 0 or 1.
yeah,
So I'm not sure like how.
yeah, okay. Well, just looking at it, if you were to sub in x equals 0 to these, what do they become?
Is it? Oh, zero. Oh, never mind.
No, that's fine. Like I get that, but like mathematically, you've seen somehow um, that the zero solution has disappeared, and that's likely an issue with dividing by x. Um,
Mhm.
do you ever, when you're solving for polynomials, do you ever divide by x?
Yeah, I have.
Yeah. So whenever you do that, you actually end up cancelling out the x equals zero solution. And the reason
Oh,
why is because when you divide by x, you've got a possibility that x could be zero, and you've in fact divided by zero under that circumstance.
hmm.
So the preferred way of solving all of these is via factorization, not by division.
Okay.
So that's why you've lost the x equals zero solution, and that will always be why you've lost x equals zero in any polynomial, whether it be a root or not.
Okay. All right.
Cool. But yeah, so did you say you tried it tech free first, and then Kaz gave you that answer?
Yeah. Yeah. I tried it tech free.
Okay, no, fair enough. Yeah, so my recommendation is just factorize instead of trying to cancel things out like that. Um, which in this case would mean, I guess, doing a cross multiply, because if you power of four both sides, you're still going to have a fraction. So
Mm.
you power of four both sides, then power of three both sides. So what that would look like is you have x to the power of a third is equal to x to the power of a quarter. If you power of four both sides, you're now going to have 4 over 3 and then just x. If you power 3 both sides, you're going to have a 4 over here and a 3 over here. X to the 4 minus x to the 3 equals 0. X to the 3 comes out the front. X cubed is equal to 0, in which case you have the x equals 0 solution that you would have missed.
Okay. All right.
And then, of course, there's that. And if you
Okay.
happen to be doing special, I didn't see. I forget which one you ticked on the poll. But if you are doing special, this has complex solutions to it as well, which is a bit nasty.
Okay.
Are you doing special, or am I just misremembering?
Oh no.
Okay, yeah, you
I'm
probably
doing general math.
yeah, you're doing the general. Okay, fair enough. Yeah, so don't worry about that last little tidbit then. Yeah,
All
so
right. Okay.
that's the preferred way of going about it. Or, better
All
yet,
right.
instead, I've found that you still can divide by x. Just make sure that before you do so, just do a quick check. Does x equals 0 make sense as a solution? If it does, just remember that and put that down as a solution and then continue on with your division. It's a bit sketchy to do that, but I've found that it still works anyway.
Oh, okay. All right.
Yeah, okay, so that's 4a there. So that's where you find the values of x for those intersections. Um, and then sketching those graphs, any trouble with that at all?
No, I'm okay.
Nice. Okay.
Yeah.
Anything else to clarify with that or other questions?
I think that's it.
That's it.
That's all.
Nice.
Yeah.
Love to hear it. Happy to help. Okay.
All right.
Enjoy the rest of your day then.
Okay, thanks.
Thank you. Bye.
So, do I just leave?
Yeah, if you, I mean, it's a free for all, whatever. So you're not required to stay. There's no agenda. It's just people that can drop in and ask any questions they need to.
Oh, okay. Is this the same for all classes or just Q&A?
Just Q&A. Yeah, Q&A to drop in,
Just
and
Q&A.
the other two are structured. So we go through student questions, then curriculum content, and then questions from textbook if we get to that.
Oh, okay. All right.
Fair enough.
All right. Okay. See ya.
No worries. Take care.
Question 7H and 1F, but there's something I was going over through it and something like, made me confused a little bit.
Yeah.
Yeah, yeah. So,
H1. Hang on. Sorry. Which one was it?
uh, 1F, question 7H. 7H.
There's no 7H for 1F that I'm seeing. Oh, that's 1G. Right. No, sorry. Yeah, yeah.
Yeah,
I'm just a silly man. Where's the real?
it's okay. We all make mistakes.
Oh, so that's what we did. Okay. Yeah. 7H, yeah.
Yeah, yeah. So for the range, so if you're trying to calculate the range for hx,
Yep.
um, there would be two options. You would get either -2 comma 0 or 2 comma 0. So which one would you like choose?
Yeah. Okay. No, I get what you mean. Um, it's the same thing as if you were looking at G, for example, where theoretically you'd have positive and negative. But in the context of how math methods does things, if you just see the root on its own, you assume only a positive solution. Um, that's how math methods handles it. You are right, yes, square root of something should have positive and negative, but as we've seen in doing our work solutions, you only ever give the positive more than negative, not both.
Oh, okay.
Yeah, this is detailed in maybe not this one. Hang on, do they have it here? It would have to be where they talk about square roots the first time. Let's see. Do they do that here? Probably, but I know where it is on chapter on unit 1 2, so we'll look at that instead. Gallery of gaffs, 4C, 144. Da, da, da. Do you remember looking at the graph of y squared equals x at all?
Y squared equals x.
It's
I
typically
think, yeah, yeah,
skipped.
I
Oh, you
think so,
did.
yeah.
Okay, good. Yeah, because usually some schools will skip it. Um, so the reason why y squared equals x looks like this, the full parabola, and
Mhm.
the root x only looks like this is because of what I was talking about before, where we're only taking the upper half of that solution of that root, the positive portion,
Okay, all right.
because theoretically y equals root x should be the same graph as y squared equals x. It's just that we're only taking one or the
Right.
other.
Right.
Uh,
So in the question body, if you see like just the root by itself without the plus or minus sign, you just assume that it's positive all the time.
if it's applied to a function, so if the question says h of x is equal to this for 0 to 2, yes, you assume that that root is only going to be positive. If it had a negative at the front, you would assume it has to be only the negative. The
Okay.
nuance there is when you're doing your own working out, when you take a square root, you need to make sure you keep plus or minus and only fix it after the
Mm.
fact if you need to.
Oh, okay. All right.
Because I don't
Got
want you
it.
to do like a quadratic, like x squared equals 1, and I don't want you to think that you don't do the plus or minus of that. It's only when the root is already given to you as a function do you take it as a positive or a negative only.
Oh, okay. All right.
Clear the difference between those two things?
Yep. Yep. I got it.
Nice.
Thanks so much.
No worries at all.
All
That's
right.
all I
I'll
can help
see
you
you
with.
later.
Okay, yep. I'll still be here for 8 minutes or so. So if any more things
Okay.
need to come up, then by all means jump in.
All right. Bye.
Take care.